Hello everyone, welcome to my next video lectures on engineering mechanics based on composition and resolution of forces. These are the contents today I'm going to discuss about, that is the basic concepts which used in engineering mechanics, force system, what are the different types of forces which are available in engineering mechanics, and the composition of forces and resolution of forces, that is how to resolve the forces and how to determine the resultant of the system. And also we are going to talk about what are the different conditions which are existed for the resultant to solve the problem. First of all, let me define what we mean by an engineering mechanics. An engineering mechanics is the branch of physical science which deals with the bodies under the action of force. It is completely dealing about the body under the application of force is called the engineering mechanics. The engineering mechanics basically classified into two types. One is statics and another one is dynamics. The statics is a branch of the engineering mechanics where we are going to deal about the bodies which are in a state of rest. Dynamics is a branch of engineering mechanics where we are going to deal about the bodies under the application of the forces which are moving. Okay, whenever I am talking about the dynamics, it is all about the portion of moving, and whenever we are talking about the statics, it is the bodies will be at the state of rest. The entire thing we are going to deal about here, it is only dealing about the statics of engineering mechanics. What is the basic concepts they use to solve the engineering mechanics static problem? Basically there are three idealization. One is a particle, another one is a rigid body, and another one is a concentrated force. What do you mean by a particle? A particle is a body of negligible dimension. If you consider a whole mass of a body, in that particular mass, a particle is a tiny amount. It is having a zero dimension or almost equal to negligible dimension. But the compositions of millions of particles together will form a body. Right? When I'm talking about a body, basically there are two types of bodies. One is a deformable body and another one is non-deformable body. What do you mean by non-deformable body? Non-deformable body is also called as a rigid body. That means the body will be rigid even though after the application of the external force. There won't be any deformation will occur on a body even the application of the external force. So the rigid body is the body with having negligible dimension even after the application of the force. The same way, what is deformable body? A deformable body is the body which has a considerable amount of deformation or considerable amount of change after the application of the force is called a deformable body. Example, you see here, there are three pictures are there. The first one which indicates a body. Second one which indicates a rigid body. Here you see there is an application of force from the top. There is no any deformation or change in the dimension of the body. It is not occurring in that particular body is called as rigid body. For the same amount, there is a third force which is there. Here there is a considerable amount of deformation or changing in the dimensions of the body which is happening here. So this particular type of body is called as deformable body. And second one, this is called as non-deformable body, which is also called as a rigid body. So third one, the third consideration will apply in engineering mechanics, that is concentrated force. Example, here you see whatever the amount of force, assume here the 10 kilonewton of load which is applied on this body, the entire load is concentrated at a particular point. So which means that in engineering mechanics should be assumed the force or the load which is acting on a body, it will be acted at a single point. The entire magnitude of the force will be applied on a single point. So the force should be considered as the concentrated force. The concentrated force is the force where the entire magnitude of the body has been concentrated at a single point. So these are the three basic idealization. One is a body should be considered as a particle, and we are only dealing with the rigid body. The rigid body is the one where have the negligible dimension even after the application of the force. And third one, whatever the force will apply on a body should be treated as a concentrated force. That is, it will be acting at a single point. And one more thing, in statics, the bodies are considered to be rigid body unless stated otherwise. If they have not mentioned which type of body it is, then we should preferably should be considered it as a rigid body. Next one. As I'm talking about the engineering mechanics is only about the body and the force, let me define what is a force. A force is defined as an action or an agent which changes or tends to change the state of a body is called as a force. Here you see, force is defined as an action. It is an action or an agent which is changes or try to change the state of the body. The state of the body, either it will be at a state of rest to motion or from motion to rest. Force is the external agency or an agent or an action which apply, when you apply it on a body, it will change or tends to change the state from either rest to motion or from motion to rest. That particular thing is called as force. While representing the complete force, we have to consider the main four characteristics of the force. That is, one is magnitude. Magnitude, which directly implies that what is the quantity of the force, or what is the weight of the force, or what is the load of the force. Example, magnitude, which always refers to the quantity, the amount. Next, the direction of the line. That is, on which direction the force is acting, whether the force is acting along x direction or the force is acting along the y direction. So we have to consider the direction of the force. How to consider the direction of the force? If you look at the arrowhead, you see the figure. In the figure, the arrowhead represents the direction of the force. This particular direction of the force, this entire line on which the force is acting, this particular line is called a line of action of force. Our line of action of force is also defined as the line on which the force which is acting throughout, it's called as the line of action. And the third one is nature of force. Either it is a push or pull, which means that the force is basically, there are two types. One is the tensile force and another one is the compressive force. Example, if you see here, I'm applying a 10 Newton load on a block. Same way, if I apply another force which having the same 10 Newton, if both the forces are acting towards the body, then it is called compressive force. That is push. It is going to push the body. Same way, the 10 Newton force, if it is, example, if it is acting along the opposite direction, here also if it is acting along the opposite direction, that is the force which is moving away from the body, that is called tensile force, or it is also called as pull. So if you define a compressive force is the force where the force will act towards the body. Here you see the force is acting towards the body is called compressive force. Same way, if tensile force is the force where the force which is acting away from the body. If the force is acting away from the body, it is called as the tensile force. So we have to mention the nature of the force and the point at which the force acts on a body, at what point the force is acting. That also we have to mention. To represent the complete action of the force, first thing we have to mention what is the magnitude of the force. The second one, what is the direction of the force, that is the line of action of the force we have to mention. Then we have to mention whether it is a compressive force or whether it is a tensile force. That also we can indicate or we can judge through the arrowhead. Next one, the point at which the force is acting. So these are the basic four characteristics we have to mention while mentioning the complete force. Next, what all the different types of forces are there? To study about the different types of forces, it is called a system of force. What is system of force? If you define a system of force, if more than one or two forces which are acting in a body, it's called a system of force. If more than one force which is acting on a body, then it is called a system of forces. The force system basically classified into two major categories. One is coplanar force and another one is non-coplanar force. What do you mean by a coplanar force? As the term itself indicating, the coplanar forces are the force which will be acting in a single plane. If you assume this is the one plane, that is the y plane, here the coplanar is defined as all the forces which are present in the particular plane will be acting in the same plane, that is called coplanar. What is non-coplanar? Non-coplanar force are the forces which will be acting in a different plane, or which will be acting in a more than one plane. It is called non-coplanar forces. Now the coplanar and non-coplanar forces are further divided into the concurrent or non-concurrent force, collinear or non-collinear force, parallel or non-parallel forces. Here you see, if I consider a coplanar concurrent force, so first I will define what is concurrent. Concurrent is the concurrent system is the system where all the forces of line of action will be meeting at a single point. Example, assume if more than one or two forces which will be acting. Example, here you see, if there are three forces which will be acting, if we know that if all the three forces which are acting, if it is meet at a single point, the line of action of the point will be meet at a single point, then it is called concurrent force. The same way, what is non-concurrent force? If the forces in a force system, if more than one point, or if the forces which are not meeting at a single point, then it is called non-concurrent force system. Next, what is collinear force system? As I mentioned, what is collinear means if the line of action of the force, if the line of action of the force which is acting in a single, this is the line of action of the force, if it is acting in a single line, it is called collinear forces. The best example I can give for this example, assume there are two teams which are participating in tug of war. The line of action of the forces from both the end will be along the single line. This is the single line where the application of the forces takes place. So this is called the collinear force. What is non-collinear? If the line of action of the force which do not lie in a single plane, then it is called non-collinear force. The same way, what is parallel or non-parallel forces? As the term itself indicating, if the forces which are acting parallel to each other, that is the line of action of the force will not meet at any point. All are acting in a single direction and they won't meet each other. The line of action of the force will not meet at any point. That is called parallel force. Non-parallel force, that means they are not parallel. The line of action of the force will meet at some particular point. Next, the same way if I define what is non-coplanar concurrent force system, that is non-coplanar is the force system where more than the forces which will be acting more than one plane, and concurrent means the system, the line of action of the force will meet at a single point. So if I define non-coplanar concurrent force system, it is a system where the line of action of the force will meet at a single point, but the forces are acting from the different plane. Some forces might be acting along from the x plane, and some force might be acting from the y plane, but they are meeting at a single point. That particular thing is called as non-coplanar concurrent force system. Same way, non-coplanar non-concurrent force system is the system where the planes are different as well as the line of action of the force will not meet each other. It is called non-coplanar force, non-coplanar non-concurrent force system. I have some example based on that. Here you see I have shown the coplanar forces. What is coplanar forces? Here you see coplanar concurrent. That means at a point, when I'm mentioning about concurrent, which means that the forces will be acting at a point, it's called concurrent. And also here I'm mentioning coplanar, which means that all the forces which are acting in a one plane, all the forces which are acting in a single plane, it's called coplanar concurrent forces. Here you see coplanar non-concurrent force system. That is this line of action of the force is acting here, and this one is acting here, this one is acting along this direction, this direction. So they will meet at a different points. So that's why it is called as, but they are acting at a single plane. So it is called as coplanar non-concurrent force system. As I given an example for collinear force, here you see the coplanar collinear. In a single plane, there are two forces are acting. but for both the forces, there will be a single line of action. So this is the line of action of the force. This force is moving towards this direction and this force which is moving along this direction. But both will be having a same line. It is called as coplanar collinear system. Same way coplanar non-collinear. They are not the line of action of the force which is not moving along the same direction. So here you see this force having a line of action along this direction, and this is having these two forces which are having a line of action along this direction. So it is called as non-collinear coplanar system. So coplanar parallel force, either it might be like forces or either it might be unlike forces, which means that what is the difference between like and unlike? You see here all the forces which are acting downwards and they are parallel to each other. So this is, and they are acting in a single plane. So it is called coplanar like parallel force, and this one is called coplanar parallel force. So it's also called as coplanar non-like forces. Coplanar non-like parallel forces. That is, they are parallel, they are acting in the same plane, but they are acting along the different direction. So it is called as coplanar non-like parallel forces. The same way, if you see the non-coplanar force system, here you see what is happening here. There is a X plane, there is a Y plane, and there is a Z plane. Here they are saying non-coplanar parallel force. That is, they are acting from different plane. Here is the one plane, here is the another plane. They are acting from a different plane, but they are parallel to each other. So it is called as non-coplanar parallel system. What do you mean by non-coplanar concurrent system? That is, concurrent means they should be meet at a single point. How they are acting? One is acting from y-axis and another two which are acting from the z-axis, right? All are meeting at a single point. It is called non-coplanar concurrent force system. Here you see non-coplanar, non-concurrent. They should not act at even at a single point, and also they are not acting in the same plane. Here you see this is the one plane, this is the another plane, this is the another plane. All the forces which are acting at different planes, and also they are not acting at a single point. So that is called as non-coplanar, non-concurrent force system. Next one, what do you mean by composition of forces? As the term itself indicating composition, which means together, the reduction of a given system of forces to the simplest system that will be its equivalent is called composition of forces. If they have assume if they have given 20 different types of forces which are acting in a single system, and if we reduce that particular system into a simplest form or simplest system, and if we find the same amount of the net effect which caused by all the forces into a single force, that particular process is called as composition of forces. That is determining an individual equivalent which having the same effect which is produced by all the 20 different types of forces. That is called composition of forces. Next one, what exactly mean by composition? Which means that determining an equivalent for all the different types of forces which produce the net effect. That particular equivalent is called as a resultant force. What is a resultant? A resultant force is also called as a net force. Is a force which is equal to sum of all the forces applied to an object. Or we can also define the resultant force is a single force which has the same net effect which caused by the system of forces. That is the entire system of forces, what is the effect they are producing, it will be given by one single force which is also produce the same net effect. That is called resultant force. The process of finding out the resultant force is called the composition of forces. As I mentioned, the composition of forces, it is all about determining a equivalent by reducing a complex system into a simpler system. It is called the composition of forces. The process of determining the resultant force is called composition of forces. It can be determined by using basically two methods. One is the analytical method and another one is the method of resolution. What is analytical method and what is the method of resolution? We'll see. First one, we'll see what is the resolution of a force. The process of splitting of the given force system into number of its whole component without changing its effect on the body is called a resolution of force. Here the process of splitting the given force, we are going to divide the forces into number of small components. Either it might be, example, assume there is a one force which is there is an inclined force. We cannot consider the inclined force in engineering mechanics. Either we can easily consider whether the force is acting along the x direction or the force is acting along the y direction. But it is difficult to consider the effect of an inclined force to x direction or y direction. So what we will do, we are going to split up that inclined force into its components, horizontal component and vertical component. That particular process is called resolution of force. While what is the main principle which involved while resolving the force or resolution of the force? It states that the algebraic sum of all the resolved parts of a number of forces in a given direction is equal to the resolved parts of their resultant in the same direction. That is, if one force which is acting along one direction, if you split up the force, then the net effects caused by a single force and the net effect which caused by both of its components should be the same. That is called as the principle of resolution. What are the different methods which are available for calculating the resultant in an analytical method as well as in method of resolution? In an analytical method, we can determine the forces, the resultant forces, by using parallelogram law of force, triangle law of force, polygon law of force. And we'll discuss what you mean by these different laws. And also we can determine the resultant by using a vector method, that is by considering the vector summation, that is by constructing a space diagram by using a Bose notation, or even by considering the construction of vector diagram. Okay, that is called as the graphical method. Now we will see what you mean by first one, what you mean by a parallelogram law of forces. The different laws which used to determine the resultant of a force, that is parallelogram law, triangle law and polygon law. Let me discuss one by one. That is parallelogram law. Here what the parallelogram law says, if two forces mentioned, note down here, there are two forces, if it is acting simultaneously on a particle, be represented in magnitude and direction by the two adjacent sides of the parallelogram. The resultant in magnitude and direction by the diagonal of the parallelogram which passes through their point of intersection. That is, example, if two forces which are acting, take here F1 and F2 are the two forces which are acting simultaneously on a particle. It can be represented by the magnitude and direction on which they are acting. The resultant of these two forces can be determined by drawing a parallelogram which have the same magnitude of the other two sides. That is, this one represents the F2 force and this one represents the F1 force. And this particular diagonal which represents the resultant of these two forces. Okay, this is what parallelogram law says. If two forces which are acting simultaneously a particle, then the resultant of these two forces can be obtained by drawing a diagonal to the particular two forces, is by drawing a diagonal from the same point, is called as the parallelogram law of forces. That is, R represents this particular force, the diagonal force, which is equal to, so it can be determined by using an equation, F1 square plus F2 square plus 2F1 F2 cos theta. And what is the direction of the force? That is theta or alpha, which can be determined by using tan alpha equal to F2 sin theta by F1 plus F2 cos theta. Okay, this is what the parallelogram law says. Triangle law of force. What is triangle law says? The same way as parallelogram law. If two forces which are acting simultaneously are a particle, that is, you see here A vector and B vector, it can be, the resultant can be represented by using the third side of a triangle. That is the closing sides of a triangle. But here the resultant should be along the opposite in direction. That is, here you see, this is the direction of the A force and this is the direction of B force. To close the triangle, I should move from this side to this side. But in triangle law, we have to move, to determine the resultant, we have to close the triangle by the opposite direction. That will represent the that will represent the closing sides of a polygon, and it is equal to resultant. Next, what do you mean by polygon law? Here, rather than two forces, if number of forces which are acting simultaneously on a particle, it can be represented by the magnitude and directions by drawing the different sides of polygon. Then the resultant of all these forces may be represented in the same magnitude and direction by closing sides of a polygon, but it will be in an opposite direction, as same as triangle law. Here you see there are four forces which are acting, that is A is acting along this direction, B is C along this direction, D is along this direction, and then I have written the closing side of the polygon, and that is R, which will be I have written in a opposite direction. So to get the resultant when the number of system of forces are acting, you draw a polygon, and it should be, the resultant should be drawn by the closing sides of a polygon, which will be in a opposite direction. Next, what is the method or the steps we have to follow for the resolution of the force? First of all, resolve all the forces which are acting in the system into horizontal force and the vertical force, and find the algebraic sum of all the horizontal components and the vertical components. When the system of forces which are acting, first we have to resolve all the force. What is resolving? If any diagonal forces are there, split into horizontal component and vertical component, then find the algebraic sum of all the horizontal component and the algebraic sum of all the vertical component. The resultant that is R can be calculated by using R equal to summation of horizontal whole square plus summation of vertical whole square. Then to determine the direction of the same resultant, that is the angle theta or angle alpha, which can be determined by using tan theta equal to summation of V by summation of H. And the last point here you see, when the summation of V is positive, the resultant makes an angle between 0 and 180 degree. But when the summation of V is negative, the resultant makes an angle which is 180 degree to 360 degree, which means that in here the basic consideration for the engineering mechanics that is taken by saying, if the forces which are acting vertical as positive, and if the forces which are acting vertically downwards as negative. Now you see, when the summation of V is positive, which means that if the force is moving along the upward direction from 0 degree to 180 degree, which is called as a positive force. The same way, if the force which is moving from 180 degree to 360 degree, that is, if the force is moving along the downward direction, then it should be considered as a negative force. The angle between them will be 180 to 360 degree. That will be discussed in next slide. Here you see, what is the resolution of force, the method of resolving the forces, right? While as I mentioned, if the one individual force which is present here, then to take down the resultant of the forces, what we have to do? First, we have to consider what is that particular force direction and how to split the component, right? Example, here you see there is one diagonal force F which is present, which is making an angle theta with respect to horizontal. Before going for this component, let me discuss this one first, right? If any unknown, if it is a vertical force, we can directly consider it for the calculation of summation of vertical. If it is a horizontal force, then I can directly take it as whether it is a positive force or negative force. Directly we can consider. But if it is an inclined force, how to resolve? If it is an inclined force, what I have to do? If the inclined force is there, then I want to split that particular force into two components, that is the horizontal component as well as vertical components. Here you see this inclined force has been split into horizontal component and vertical component. What is the principle of resolution says? Even though if you split this individual force into two components, the net effect gained by this individual force will be same as the total effect which caused by these two particular forces. So if the inclined force is there, then we can easily resolve the force into horizontal component and vertical component. Why I want to resolve into horizontal and vertical component? Because for calculation of summation of horizontal and vertical, I want to take the forces which will be along the x direction or which will be along the y direction, right? So that is the reason we have to resolve the forces. Now let me come here. So that is what you mean by what are the different cases we basically face while resolving forces. Example, if this inclined force which is making an angle theta with respect to horizontal axis, that is here you see with respect to horizontal axis this theta which form, then the horizontal component, that is f of x of the force, which is equal to f cos theta, and the vertical component should be f sin theta. Only thing we have to remember, when the inclined force is there, I want to resolve into horizontal component and vertical component to resolve the force. If theta which is making an angle with respect to horizontal, then the horizontal component is f cos theta and the vertical component is f sin theta. Same way, if the theta is made with respect to vertical, then the horizontal component will be f sin theta and the vertical component will be f cos theta. Based on where the theta has formed, on which axis the theta has formed, the component of the force will change. Here you see the theta has been formed with respect to horizontal, so horizontal component is f cos theta. Here the theta has been formed with respect to vertical, so the horizontal component is f sin theta. Alright. Same way here also some of the example, that is here you see the force has been made in the third quadrant. Here the theta has formed with respect to horizontal axis. Therefore, the horizontal component is f cos theta, the vertical component is f sin theta. The same way in where also you see in third quadrant the theta has been formed with respect to vertical. So the horizontal component is f sin theta and the vertical component is f cos theta. Okay. Next one, here you see the sum of the conditions I have given to solve the resultant or in inclined force. Example, if they directly given the direction of the force, that is f, then this will be f cos theta and this will be f sin theta. The same way, what we have to do, if example the theta has been formed with respect to vertical, sorry, here I have mentioned with respect to horizontal. The example, if theta has been formed with respect to vertical, then the horizontal component is f sin theta and the vertical component is f cos theta. The same way, rather than giving the direction of the force directly by theta, if they are given the slope, example here you see for the inclined force they have given 10% slope. We basically know that while representing the slope, it should be represented, that is how much the distance has been covered horizontally with respect to one vertical unit. How much horizontal unit it has been covered with respect to one vertical unit. The same way here they have given 10% slope. So 10% slope equal to 10 by 100, which is equal to 0.1. So what is 0.1? 0.1 equal to the slope. Basically, how to measure the slope? The 0.1 will be equal to the tan theta. That is, slope will be measured in terms of tan theta. So tan theta equal to 0.1. So theta equal to tan inverse of 0.1. So assume, let's take it will come around 48 degree. So tan inverse of 0.1 equal to 48 degree. And also one thing we have to observe that while taking the tan theta, we basically what we do, we do the tan theta has been, or the slope has been defined by considering the theta along the x-axis. That is, the tan theta has been defined, assume it is a triangle or a slope. While defining the tan theta, it has been taken, that is opposite side by adjacent side. So vertical by horizontal. So which is equal to the tan theta. So theta equal to tan inverse of 0.1. Then we'll get what is the angle or the direction of the particular force. The same way here, one more condition they have given. What is they given? They are given the coordinate points of a force, that is x comma y. Assume the x equal to 2 and y equal to 3. That is how to represent x equal to 2 unit and y equal to 3 unit. Then we have to close the triangle. Then we have to take the theta by considering that, by defining the tan theta. What is tan theta? Which is equal to opposite side by the adjacent side. So I have to consider this as 3 and this as 2. So which is equal to tan theta equal to 3 by 2. So theta equal to tan inverse of the particular angle. So the direction of the force when they have given the coordinates can also be easily calculated. Last one here you see they have represent the slope in terms of the numericals. That is the 3 vertical units has been raised for 5 horizontal units. So how to determine the theta here? That is we have to form a theta here by drawing a triangle. That is theta here. So vertical axis is 3 and the horizontal axis will be having 5 units. So tan theta equal to 3 by 5. So theta can be taken with respect to tan inverse of 3 by 5. So we can also get the theta value. So one thing we have to remember, slope should be equal to f of y by f of x, which is equal to tan theta, and always the tan theta is taken with respect to horizontal axis. And this is the end of the chapter. Thank you.